In 1C, we are asked to show that y is a solution to this differential equation. So we have a series for y. We can put that here. And we also need a series for y prime. So y prime is the derivative of the series. We can take the derivative of every single term using the power rule, 2n times x to the 2n minus 1. Everything else is just constants. All right, notice right away that when n is equal to 0, this first term is 0. So we might as well rewrite this with a lower index of n equals 1, which gives us that first term. All right, let's do the substitutions. So we'll substitute in this series for y right there. So 2x times y, 2x times that series. And we'll substitute in this series, which we're rewriting this way, for y prime, which will go right there. So does that solve this differential equation? Is the left side equal to 0? Well, if these were opposites of each other, then they would have a sum of 0. So let's see if we can rewrite these so that they are opposites of each other. We could take this 2 factor and put it on the inside so it matches this 2 factor. Or we could pull this 2 factor out front. It doesn't really matter. I'm going to pull this 2 factor out front. And then we also want to have an x out front. So let's take one of these x factors and pull that out front as well. If you factor out x, we'll be left with x to the 2n minus 2. Next, there's no n in this numerator, so we can factor this n out with this n. This is 1 times 2 times 3 all the way up to n factorial. So if that n factor gets canceled out with this n factor, the last factor is n minus 1. Now we are really close. We have the factors matched. The expressions are really close. The lower indexes don't match. So we'll bring this lower index down from 1 to 0. And when that goes down by 1, then every n in the expression has to go up by 1. So down by 1, up by 1, up by 1, up by 1. What does that leave us with? This is 2n plus 2 minus 2, or just 2n, matches. N plus 1 minus 1 is just n factorial, matches. The lower index and upper index now go from 0 to infinity in both expressions. And this negative 1 to the n plus 1 is negative 1 to the 1 times negative 1 to the n. So we'll factor that negative 1 out front. And there we have it. We have the identical series, except here we have 2x of them, and here we have negative 2x of them. We've shown that it's equal to 0, so we've shown that y, the original series, is a solution to this differential equation.